Good afternoon. This is Schweitzer. We're going to talk a little bit about like our second video here on energy. And the question we have here is, how do we know how much energy something gives off? We might want to say, well, how do you collect that? Think about that for a minute. We just sometimes we burn a gummy bear in class, and we're trying to say how much energy is coming off of that. We only get a little bit of energy, like this marshmallow's getting a little energy here. You feel some energy coming this way, but the energy is also going that way. So energy is emanating in just about every direction. It might be going more up than anything, so how much energy does something give off is an interesting question, and a question that scientists and chemical engineers had to kind of face if they want to know or make it more mathematical. So this idea is called calorimetry, is sort of this process of collecting energy. Now we're going to just talk a little bit about transfer of energy in this video, and then we'll go more to the math side of it, and eventually we'll circle back around to actual calorimetry. So again, energy transfers from one object to another object is kind of how we collect that energy. That's what they're going to do. For calorimetry is really the collection of energy. So we would build some device maybe that would go all the way around it, and then that device would absorb the energy. Okay, and that's kind of where our video today is going to pick up. How do you collect energy? If an object does collect energy, what does that mean? Does it have the same temperature change? What's going on here? So that little dynamic of how you transfer energy from one object to another object is really going to be the task of our next video or two. So let's do some thought experiments. So remember, energy can take many forms. Before we attempt to collect energy, all energy, we need to be able to clearly define the difference between energy and temperature. So make sure we understand, well, this is something that we're going to be moving towards. When in the end, when we're all done with this thing, we're trying to figure out, what does it mean to be hotter or energy? Okay. So let's say, for example, which is hotter? A 5,000 gram, so pretty heavy, gram iron block at 25 degrees Celsius, or a 0.005 gram, really tiny little spark. Now, everyone here probably has had these little sparklers. They're pretty fun. They just sparkle off. But occasionally, as you grab on this thing with your hand, okay, you might notice a piece of shrapnel come off, land on your hand, and it got a little pick to it on your hand. Okay. So with that being said, these little sparks that are here, okay, are actually pretty hot. This little spark laying off on your hand is about 2,000 degrees, super hot. So which is hotter? Well, obviously 2,000 is bigger than 25, right? So you could even go 200 degrees. Okay. Let's change this out here from 25 to, let's say, 250 degrees. Okay. Now on this thing, let's go and move it here. There we go. So 250 degrees Celsius. That's pretty hot too. But this is way hotter. So next thing it says, okay, which one's hotter? Well, this one's hotter. Which one contains more energy? You may even say, if you put both these in your hand, which one burns your hand? Which one burns your hand if you touch it? And obviously it's going to be this one. This one actually contains more energy in that sense. So even though this one's hotter, this one burns your hand because the temperature is not burning your hand, it's the transfer of energy. Sometimes you might see someone where they have a hot pan, and especially if you're a kid, maybe you see someone of your relatives pick up a hot pan and transfer it very quickly. Oh, how did you not burn yourself? Well, hot's one thing, but if you go fast enough, the energy still has to transfer to your hand. Okay, so with that being said, if you go fast enough, you may not give enough time for energy to transfer, and you won't burn yourself. So the total energy really is what's going to cause your hand to burn, not necessarily just the actual temperature. Either way, so in this case, we've answered a couple of questions here. Let's try another example. Let's say we have, again, thought experiment, 25,000 grams of iron at this temperature. Set that out, so that's like room temperature. Set it on a block of ice, and then you take 2,000 degrees of 0.005 grams on ice. So this is like your sparkler, spec. Okay, which one melts more ice? Again, this one's hotter, but this one contains more energy because it's got more mass. Okay, so this one melts way more water. Lots more water. Why? Well, not because it's at more temperature, but it's got also more mass. So the energy, there's got to be something going on here between energy that a substance takes in and out, okay, in and out, and temperature change. That isn't as simple as what people thought it was. They thought, oh, temperature, energy, same thing. Two objects have the same change in energy, they should have the same change in temperature. That's just not the case, and it really threw humans off for a good 2,000 years. Okay, there's several factors that affect this, and you can see with this one, they're both iron, so obviously the mass, how big an object is, has a drastic effect on how much energy it can absorb. So if this thing is 4 times bigger than the small one, then it can take 4 times the amount of energy for the same change in temperature. So not only mass, but temperature has an effect. Okay, so another one here. So in this situation, another thought experiment. I take this 2,000 degree block. Okay, we know that we've already discussed these things, right? This is the little iron speck, very hot. You set it on top of a 25-degree block. Set the small block on top of it. Which way does energy flow? Think about that for a second. Which one gets hotter because of it? Energy flows, and you're not going to have energy flow one way and then get colder. What I mean by energy is not going to flow. So, well, first of all, energy, which is going to flow, it's going to flow this way. So we talked about this already. Energy flows not by total energy. Okay, energy flows from high temperatures to low temperatures. That's pretty amazing. Even though this one's never going to burn your hand, this one will. Energy flows from this one to this one because it's hotter. Now, there are several factors that determine how much energy a substance has. We know the total energy an item has is involving the temperature, is involving the mass of the object, and there's another one here which is unknown for people for a long time, but it's called C, which is specific heat. Okay. Now, the specific heat is another entity which we'll talk about here coming up. Okay. So the main takeaway: energy transfers via temperature. Keep that in mind. All right. So two objects have the same mass, absorb the same amount of energy. Are they guaranteed to raise the same degrees? Two objects have the same mass, same amount of energy. So now we're even getting two things. We're including lots, same mass. Okay. So same size, same energy. Now are they guaranteed at the same temperature change? Same energy. Okay, and the same temperature? Same change? And the answer is, once again, still no. We're coming now down to this idea of what we refer to as specific heat. Okay, one pencil. Okay, and this idea of specific heat is, I'll type it in here, is called specific heat. So even if you have the same mass, same temperature, specific heat is for particular substances the amount of energy a substance needs to raise 1 degree Celsius. So not everything has the same specific heat. Some things inherently take more energy than others do. Okay, so with this idea of specific heat, you should be aware of the fact that, it's possible. It's quite possible, and maybe even absolutely, that if we have two substances that have the same mass, okay, same energy, call it Q, is our typical thing for energy, they could have a different change in temperature. And the answer is yes, and that's due to specific heat. We symbolize specific heat with a C, and that is the energy per mass per degree Celsius or Kelvin. And some things just inherently can absorb and hold more energy than other things do. And with that being said, our next time we come around here, we're going to do a little bit more of a mathematical look at this transfer of energy. Thank you.